Hello and welcome everyone. This is part 5, the last one in the series where we are building an AI powered chat application. So very first video talked about the demo and the key concepts. The second one, we went over the front end to back end communication, how fast API server was acting, how we were doing the session management and all that. The third video, we looked into how the request response and state management was being done, right? So the session details were being talked about in the third video. And in the fourth video, we saw the tool calling or the function calling aspect of large language model, both in OpenAI and Ollama. Ollama now having the same chat completions endpoint supporting tool calling similar to how OpenAI does. We took a look at that in the fourth video. In this video, which is the last in the series, we'll take a look at end-to-end flow, how everything comes together, and how we are going to use multiple tools at the same time and making them available to the agent. So as a summary, our large language model AI powered chat application is a web browser based application where we send a request to our fast API backend server, which in turn sends a request to the Ollama server. In these requests that the fast API backend server does with Ollama, we tell our Ollama server that it has access to certain tools. In the example that we saw previously, we had access to get weather API tool, whereas in our full-fledged example, we'll make multiple tools available to our request response calls between chat endpoint and Ollama server, right? So then it will be the responsibility of the large language model to determine which actual tool call it wants to do. So if you're asking a complex question, then that would translate into multiple tool calls, which in turn will be reprocessed by the Ollama server before sending the response back to the user. So let's see how all that comes along. This is our code base, and there are two main sections of this code. One is main.py and another one is app.py. So main.py is a sample implementation in the console, so in the terminal, right? So it's a terminal based application, and the app.py is a full-fledged web browser based application. So I would recommend that please go take a look at what this main.py is, which is what I'll explain first, and then we'll graduate into talking about app.py after. So in this main.py, let's execute it, let's run this, and that is the best way to take a look at this application, right? So let me go ahead and first terminate the app.py that has been running over here, and let me kill this particular server. And let's go in and execute our main.py over here. So Python main.py, and this is where we have our user response. So the application is waiting for the user response. So let me put this together right next to it so we can have our request responses and the code right next to each other. Everything nicely organized. All right. So at this very instance, when we are waiting for the user request, I'm going to go at the very bottom of the code over here. If I can scroll. All right, right there. So you see the conversation starts with process conversation. So line 215, this process conversation is where the code execution actually starts. So let's go over there in this process conversation method. And over here, you'll see that we are doing messages.append system message, right? So we are taking the system message and we are appending two messages. But how is this working? So what I've done is I have created a helper class, right? So I've created a helper class that will take in any message, it will convert it into a system message, and then it will append it over here. This append function will append it to the messages empty variable. So if you go on the very top, that right here, there is an empty messages array. and we are converting this constant, right? So there is a constant of system message constant, and that will be converted to a system message. What is a system message? System message is a message with a role of system. And please watch my previous videos in this series to understand what the context and what the role of a message actually means. So how are we doing this? So let's take a look at this messages.py file over here. So in this messages.py, I have defined a class. And in this class, there are 4 different kind of messages that can potentially exist: user message, AI message, system message, and tool message, right? So there are 4 different kind of messages. In this, every message will have 2 bare minimum attributes. They are role and content. These 2 bare minimum attributes will exist in every message. And let's take a look over here in our diagram, architecture diagram. So there are 4 different kind of messages: system, user, assistant, and tool. And these 4 are mapped over here. So there is a system, user, AI message or assistant message, and tool message, right? So these are the 4 different kind of messages that we have. And in this, every message will have these 2 properties, which is role and content. However, AI message on top of it can also have tool calls property, right? So in some complex conversations, once the AI message is returning that you need to do a tool call and then provide that information back to me. So in those complex situations, AI message can have a tool calls property, which is represented over here. And then there is the 4th category of messages, which is the tools messages itself. And the tool messages will have an extra attribute called tool call ID, right? So tool call ID is actually correlated with the AI messages tool call IDs, right? So when an AI message says that, hey, you got to run this particular tool to give me the response back, and it generates a tool call ID over there. Now in the tool message, you have to include that tool call ID so that AI message can correlate the tool call IDs and make a meaningful answer from there. And we'll take a look at it once we run this application. But I wanted to explain these 4 aspects of messaging where we have 4 different roles, and they are all defined over here in this particular class. And all of them are extending from your message class, and some of them like AI and tool have extra attributes, but all of them have role and content at the least in them. All right. So once we go ahead and create our very first system message, so let's take a look. So we created our system message over here or over here, either way. Now we have to add a user message to it, which is what we are waiting for. So we haven't added a user message yet because we are waiting for the user input, right? So there is a get user input method. Let's go over there. There's a get user input method, which just returns the input of whatever the user has entered over here, right? So the get user input method is just waiting for the return of the get user input. All right, so let me go back where we were, and we are right here at this point. So if I ask, what is the weather in Woodbury, Minnesota, right? That's the question I asked, and it formulated a request over here. And if you see, this has a whole system context, whatever we have added, and there is a role user, and this is the message that was added over here. Let's take a look how it is adding, right? So right here, it took that particular input, and if I had typed exit or quit, it would have exited the application, but it did not because we did not type exit or quit. We typed what is the weather in Woodbury. So it went forward and it appended the user input as a user message, right? So remember in the messages class, we have a user message. So it appended the user message type to messages. Now we move down and we do a send request to AI, right? So this send request is now an actual call to Ollama server. So now this is the first time we are doing a call to Ollama server, right? So there is no web page over here, and we have our just Python script. So think of this as a Python script over here, which has just at the first time sent the initial user request to the Ollama server at this time. And this is the response. So we have added all the tools along with it, right? So let's take a look. What constitutes the send request, right? So let's take a look. So in the send request, what we are doing is we are taking the initial request, right? So this is the payload that we have. So it says that print the colored payload over here. But what is the payload? The payload has the model name. It has messages. So whatever messages that we have generated. So up until here, this is the messages, right? This is the messages attributes right here. And then we have tools. So what are these tools? So these are, let's take a look over here. There are 3 tools that I have associated. So there is a get weather tool, lookup Wikipedia tool, and search DuckDuckGo tool, right? So now that we are taking a look at that, before we proceed what's in those tools, let me show you what tool definition does. So what it does is there is a comma separated list over here if you see, and there are 3 functions in this tools now. First function is get weather function, right? So it had extracted the definition of get weather function from there by this tool definition aspect of it. And then in the second part, there is a lookup Wikipedia tool. It has extracted the tool definition of that. And then there is a search DuckDuckGo tool, and it has extracted the tool definition of that, right? So 3 tools have been associated over here. How is this tool definition working? So this tool definition is working because all these 3 tools that are mentioned are right here. So there is a tool internet search, which is the DuckDuckGo search, tool weather, which is the weather API search, get weather search, right? And the third one is tool Wikipedia, which is lookup Wikipedia tool. So on all of these, if you notice, there is this custom tool annotation, and I have went in depth in the previous video about what this custom tool means, right? So please watch the previous video if you want to understand what this custom tool means. But this is what is helping us in extracting the tool definitions from here. Okay, so once we have extracted the tool definition, now we are in a spot where we'll be able to formulate our request with all these 3 tools in it, right? And then we are saying, hey, keep alive is -1. And now we are, after that, we are sending our request. So if you see the send request object, we have formulated our payload, we are printing our payload, and then this is down here, response is equal to request.post and API URL, right? So this is where we have defined our API URL on the top, and we are sending the request to the Ollama server, right? So the Ollama server sends the response back. This is the response that we got from the Ollama server. And the response says that there is no content in here, right? So the content is none. However, it says that there is a tool call. If you run this particular tool, get weather tool, with the location Woodbury, Minnesota, then you'll be able to get the response back. So this is the output of the initial tool callback. So we have constructed system and user messages, and we have sent it to Ollama server. And Ollama server's first assistant response is what we are taking a look at over here, which says, hey, just run this particular tool and with this particular attribute, and you'll be fine, and you'll get the data back. And then this is what we get back. Now let's go back to our code and see what the code does. So once we have received the response, right? So once the send request is done, after that, let's go back. Let's go back over here, process conversation. So process conversation, right? So we have sent the request and we got the response data back. The response data is what we are looking at over here. And once we get the response data back, at that time, we print our response data and we extract the AI message from it, right? So the extracted AI message is right here. So we have extracted the AI message and we have printed it over here. And then we have also appended the AI message, right, to the dictionary. So this is important because we have taken the AI message out and we have appended it to the next request payload. And then we are executing the function calls. So what we are saying is that if there are any function calls or tool calls in this particular AI message, then extract it out and insert it into our next payload. So it took but before inserting into the next payload, it took the function calls out and it is still going to execute the function first before it can insert into the next payload, right? So I jumped ahead a little bit, but at this point of time, this is where we are at. We have the system message, user message, the first assistant message that says run the tools. We haven't run the tools yet. So we are extracting the tool calls and then we are going to run the tools in this particular section over here now. So we are checking if there are any tool calls. Right? In that case, we are extracting the tool calls and then we are running it over here. So the way we are processing the tool calls over here is let's go over here at tool call results, and we are taking each and every tool calls, iterating over that, and we are checking if the tool call is get weather, look up Wikipedia and DuckDuckGo, and if the mandatory attributes are present over there or not. So this is a generalized just an argument validation. You don't need to have that, but I was noticing that when I use a smaller model like Llama 3 8 billion parameter model, then I needed to do some kind of attribute validation. Otherwise, this is unnecessary and we don't need to do that. With 70 billion parameter model, I never needed to do this. All right, so if all the validations and everything else is adequate, then we are going to run the tool. So we are doing an actual tool execution over here, and we are extracting the tool message out, right? So remember there's a tool message in this messages.py. We are extracting the tool message out by passing the content, tool call ID, which is an extra parameter that tool message needs, and we are allocating it to tool message attribute. We are appending the tool message to the tool messages attribute, and then we are returning this back out, right? So now once we have created the tool messages, so I'm going to scroll down to show you what a tool message looks like. So a tool message will look like this. So the request payload will contain the tool messages, which is right here, role tool. So role tool and content this and tool call ID of this, right? So this one section is one tool call that we are looking for. So it says that the weather in Woodbury, Minnesota is whatever, and all this is extracted from here, and we have associated into tool messages section, and then we are associating it back to the final payload, right? So let's go back to our process messages conversation section. So we had system message, we had user message, and then we are checking in the response data if there are any tool calls, and if there are tool calls, we are going to add tool results. So we went to the method that we just took a look at, and the response of that was this particular structure over here. So that a tool structure like this is the response. And in here, you can see there is a role tool content and tool call ID, which is the response of this, which is tool messages. And then we are adding that to the messages original object that we had. And now that we have added that, we can scroll down and we send the final response data back to the send request method, right? So we have formulated this whole thing. We have added the tool call at the bottom over here, and we are going to send this whole request again to the large language model. And the large language model or Ollama server now. So we are at this point at this time. So we have constructed system, user, assistant, and tool. We have added tool also to the messages. And this is where the next send request is happening, right? So we are at this point. This is where the next send request is happening. And this is going to send the information back, and we are going to print whatever we receive back in green right here. So this is the final answer that we get. The tool used for this answer was weather tool. The location provided, Woodbury, has clear conditions with current temperature of 66.7 degrees and high low temperature of 76.6, right? So all this information it got back because we have provided this information by running the tool that the assistant had asked it to do. All right. So now it is going back into the loop, and this is the important part that see after it is done, it is looping back. It is going all the way back because the original condition over here is while true. It's an infinite loop. So in this infinite loop, I have two options. I can say exit and I can exit out, and it is done. And this is achieved by typing exit over here and checking for this condition. Or if I keep on running this program, it will keep on looping like a regular command line based interaction for you, right? So a chat interaction. If I can say, hey, what is the weather in Woodbury? And let it send back. And I don't know which Woodbury it will take. It could be Woodbury, New Jersey too. There is another Woodbury over here. So it will make a determination. And I don't think it works. So I do not think you answered me. And this is where the 8 billion parameter model sometimes doesn't work very well. So that is why it is kind of getting stuck. So let me ask it very clearly. What is the weather in Woodbury, Minnesota? And I think this time around, it should get a proper tool response back, and it should give me the correct answer. So high of 76 and low of 56. And if I say, how about New York, right? And let's see if it can figure out that we are talking about weather. And 8 billion parameter struggles with these things sometimes, but looks like it did. It did do it. So in this instance, I think it tried to look for all three tool calls over here. Which one did it do? So get weather and New York. All right. So it did do a get weather on New York, and that's how it was able to get the answer, right? So let's ask it a different question, which invokes not the weather, but some other function, for example, an online search. So let's see. Can you look up online to find out some information about New York? And let's see if it goes. And what it does, let's see that. So which tool it decided to run. So it ran Wikipedia tool. And in Wikipedia, it passed in the query as New York. Instead of doing DuckDuckGo search, it decided to look up Wikipedia over here, which is very interesting because I had very clearly asked it to look up online, which I mean, it did believe that Wikipedia is also an online search, so probably it did that because of that. But anyway, it extracted this summary from Wikipedia, which says Wikipedia summary for New York. New York most commonly refers to New York State, a state of northeastern United States and whatnot. And let's see what does the final assistant response was. It was the tool called Wikipedia allowed us to see more general information about New York. It seems that there are multiple meanings for New York. If you provide different topic, I can use the DuckDuckGo search tool. Oh wow, so it knew that it has another tool, but it chose to use Wikipedia. Let me ask it again. Can you look up same information in internet search tool? And let's see what it does. So we are doing a natural language. Oh, so it is doing it. If you see search DuckDuckGo and query New York online information. So it is using our natural language to create this particular request, and it did do a DuckDuckGo search to get an answer out of it, right? So it got a bunch of different details, and then it will massage that information, and then it will put it together for us in a more meaningful way, which is pretty cool. And up until I say exit over here, it will continue the conversation, and which is what it did. So this is a very simple example to show how our terminal based application works. But the reason why I have added this over here is so that you can see every single request and response that happens when you are interacting with a large language model. So in terms of understanding how this whole messaging conversation is working, I would highly recommend, how the structure is laid out and everything. I would highly recommend that you go through this main.py and understand how we have structured the code over here. Understand how we are appending system message only once, then user message after that, then assistant tool assistant messages, right? So system user assistant tool assistant, and then user assistant tool assistant. So this kind of structure that is being built over here, this is very important, and I highly recommend you guys to go over there and take a look. After main.py, we will graduate to app.py because that is the core of our actual real application that we have. So in this app.py, it just steals the ideas from main.py. However, it provides a wrapper in a way around, well, the code is rewritten, so you can even delete this main.py and it will still work. But the code in app.py is rewritten so that you can have your code restructured in the fast API based structure, right? So what we have done over there in app.py is that we have created 3 endpoints. We have 2 REST API endpoints, /session and /chat. And /chat is the endpoint that is replicating our main.py's process conversation loop, right? So this main.py's process conversation loop is being replicated in the /chat endpoint. Let's take a look at that. So if I go over here and do /chat right here, app.post/chat, this is where we are getting in the user input from our web browser. So let's do that. Let's run the app.py, and application startup is done. And I'm going to just go over here, AI chat, and hit enter. And this is where the first interaction happens, and we hit get session, right? So the JavaScript has kicked in, and it has on load of the web page, it has done /session, right? So get of /session. If you want to see which JavaScript I'm talking about, watch the very first, actually the second video, right? The second video that says front end, back end communication explained, part 2. That is where this particular JavaScript is what I'm talking about. And then a WebSocket based communication is initiated. So we get the session ID from this particular endpoint, and then we initiate this particular WebSocket based communication. So this /ws is also in our script over here, where we have down below, we have started the WebSocket based communication, and we are doing the request response in a way it's a bi-directional communication, right? So we are passing in the data directly by opening up this particular WebSocket communication based on the session ID. All right. So in this /chat, we are taking in the user input. So let me do a hello and prime our date, our model over here, right? So we want the model to load in this particular uh, 3090s graphics cards over here in the Ollama server. So my Ollama server hosted at ai.mtcl.lan colon 11436. It touches these two graphics cards over here. All right. So now that we have sent the initial request, it is priming it. It is loading the 70 billion parameter model in these two graphics cards. And it is eventually going to send the first response back, which is what I'm waiting for right now. So in the very first response back, there should not be any tool call, but if there is, we'll get to see over here. All right. So it says, it does some logical reasoning. It says that, yeah, there is a greeting provided and whatnot, right? So we are getting the response back and a slash chat was called. The point I'm trying to make over here is that in this communication, this slash chat is building the whole message communication that needs to get sent back to the large language model next time too, right? It is not being picked up from UI. These attributes and values are not getting picked up from UI. They are being maintained in a session on the server side. And this is very important that we are creating a session and these messages are being stored in a session. So we create a session store and we are having a session ID. And from the session ID, we extract these messages and then we append these messages back over there. And this is very important aspect of it. So if you go at the bottom part over here, you will see that we are setting the session stores session with the session ID back with the messages, with the updated messages that we have. So we extract this message from the session initially, and then we do the whole dance of creating a system message, user message, AI message, and tool messages. And after we are done doing all that, we update our session back with the messages object and keep it ready for the next iteration and the next run. So this is the most important aspect of the chat endpoint that I want to talk about, because how we are managing the session is explained in this slash chat endpoint, because we can potentially have multiple users access this endpoint and each user can have his own session. Each session we are maintaining on the server side. We are not passing in all the attributes from some kind of JavaScript to the server. All this is being maintained on the server side. Ideally, you can instead. So right now, like if you kill the server and if you restart it, there is no memory for the server because this is all maintained in the server's RAM right now, right? So it is just maintained as a Python variable. But ideally, you can put all this in a Redis cache. So we can create a cache. We can store all the session attributes in the cache, even if the server dies, right? It doesn't matter. Or if you're having a load balanced server, so all the servers can access the same common Redis cache and they can access it and they can write on top of it. We can do some kind of concurrency, resiliency over there. But this can be made even more robust by adding, some kind of Redis cache that can store these session attributes for us. Anyway, for this, all I wanted to show you is this particular slash chat method, which is taking in our session attribute, taking it each individual user input attributes, building that whole message object on the fly, and sending it back, to the large language model as we proceed. So let me ask some other questions over here. For example, a complex question would be, um, what is the um how many Disney Disneys are, let's just do that, Disneys are in US, which is having cooler weather. I want to go to a nice, cooler weather Disney. Let's do some grammatical mistakes too, and let's see if it can figure out what we are trying to say, do some calculations, and then come back. So I'm going to take a look over here on the server side and see what kind of requests it is doing. So it did a first request to slash chat endpoint, and I saw the server's GPU spike, which means that it has already done the AI call. Right now it is doing the tool calls. Okay, so it did some tool calls and it is sending that request back to the AI model. And let's see what tools it called. So it went in and it did a tool call for CRNG, and I'll come to this in a second, but you can correlate to this as your DuckDuckGo search engine. And so it went to our internet search engine and it got some results back from there, passed all the results back to the Ollama server, and then came back with this particular answer. So the answer that it got back was Disney has two main theme park resorts located in United States, Disneyland and Walt Disney World Resort in Florida. Walt Disney World is more likely to have cooler weather than Anaheim, especially during winter. Orlando temperatures tend to be lower. So this is not right because it is not winter time right now. So let me ask, can you validate this answer by looking up current weather situations, right? This answer. And let's see what it does. So it is now sending a request back to the AI model. It has responded and it is running a tool call. It got the tool call and then let's see. So based on the current weather situations, Orlando, which is home to Walt Disney World, does not currently have cooler weather. Temperatures are in mid 80s and high of 90s. If you're looking for a nice time to visit Walt Disney World, the weather is cooler. Plan a trip during December. Okay, all right, I get that. But can I visit another Disney location then? Can you compare its weather to this one? So see, I'm not specifying the name of the city because the context of the conversation already has the other city in the context. So let me see if it can figure out that I wanted to compare this to Anaheim. And then will it do a tool call for Anaheim, right? So it has done the request and it has sent a request. Oh yeah, it did. So it did do a request for Anaheim and it already knows the answer for Orlando. And let's see if it compares it. So it says based on the current weather situation, Anaheim has milder temperatures than Orlando. It is currently 70s with highs of 80s. If you're looking for a Disney location with cooler weather, considering Disneyland Anaheim instead of Walt Disney World. Yep. So it did do it. So it is recommending to go over there, but I had to guide it a little bit. Normally with a 70 billion parameter model, I've noticed that it kind of works out of the box. So this is the demo. This concludes the demo and explanations of how this application is working. We have several endpoints in picture. We have a session endpoint that creates the session at the start, and then this session is being stored on the browser side, and it's browser's responsibility to send that session every time in the chat communication and to keep a WebSocket open for WebSocket with that session, right? So this initial session that gets created will be used by /ws endpoint, the WebSocket endpoint, and the chat endpoint for maintaining the state. The state in reality is maintained on the server side in that session attribute. So the session store attribute. So from the session store, we keep the state maintained and we update the state at the end of the chat and we retrieve the state at the start of the chat. And in the /ws WebSocket interaction, we have the /session ID over here, and we keep a real-time communication going, which can send the data to the chat object over here, right here. So whenever we type something in here, it sends in the real-time update of what the AI model is actually doing, and it can populate that information over here too. And that is what /ws2 does. The tools part of it, anytime when the chat endpoint, which is responsible for building all these messages, interacts with Ollama server, it not only sends it the request with the current user message, but it also includes all the tools that the chat endpoint can run internally. In our case, those tools are internet search tool, so DuckDuckGo or CRXNG. It is Wikipedia. It is, we have several tools over here. So Wikipedia, whether internet search tool or CRXNG tool. We provide all those tools to the chat completion endpoint in Ollama, and Ollama is obliged to return back with either a tool call response, which the chat completions endpoint runs. And then once it is done running it, it associates it to the list of messages and then sends it back to Ollama server. So every time when we hit end send over here, all the previous messages are being grouped together and then they are sent. So now all that being said, there was a tool called CRXNG that I was talking about. So this tool is a free open source internet search tool, privacy related internet search tool that you can deploy in your local, and you can configure and customize which other search engines you want the data from when you are using this tool, right? So in our case, we have configured it for Google, Bing, and DuckDuckGo. And there is a Docker image that you can just spin up and you can utilize this tool. But in case configuring a Docker image and then utilizing this tool, CRXNG tool, for this application is too much for you, all you can do is just disable CRXNG and use the regular internet search tool, which uses the search DuckDuckGo method. And in order for you to do that, let's configure and let's see on the fly over here. So in app.py over here, all you'll have to do is over here, you'll have to, in the tools call, so let's see. So we are importing weather tool, lookup tool, and we have already imported search DuckDuckGo tool, right? So in the tools call over here, you can comment out this section. So you can comment out search CRNG. Well, it is called searching. So the X stands for everything that is missing from the searching, right? So it is a SEARCHI, which is X, and NG. So it should be pronounced as searching, but CRXNG, whatever you call it. So it is a CRXNG tool. You can comment this out and you can enable this. And you can comment this out and enable this in the tool functions. And over here, you can just replace this with DuckDuckGo, and that's it. So these three changes, if you do right here, comment and uncomment and comment and uncomment, and then replace this with your DuckDuckGo, you are good. That is actually it. I think I really enjoyed making this video series. I really enjoyed coding this app because now I can attach any number of tools that I want, right? So I can keep on adding more tools by creating more tools over here and just associating them over here. And on the fly, these tools will be utilized by my agent. And this is a nice way of starting with something small and slowly building and adding tools to an agent for you. All right. Thank you everyone for watching this video. As usual, the code's in the link in the description, and the link to all the videos in a form of a playlist is also attached in the video description. Thanks everyone for watching, and I will see you guys in the next video.